Let's now move on to a topic that really lies at the heart of warehouse operations, the core warehouse processes. This slide provides a structured overview of the typical activities that happen inside a warehouse, from the moment goods arrive until they leave the building. And even beyond that, if we consider returns and disposal. The layout here follows a logical process flow, starting from the supplier side on the left, moving through internal warehouse activities in the middle, and ending with delivery to customers on the right. There is also a feedback loop for returns, indicated at the bottom. Let's walk through this model step by step. I will not only explain each process, but also show you typical challenges and examples from practice. Also, much of the course following this video will be structured along these processes. We begin with the incoming flow, supply from suppliers. The supply side includes all upstream activities needed to get goods to the warehouse. It starts with procurement, that is, deciding what to buy, when to buy it, and from whom. Procurement isn't just about signing contracts. It's about making sure that the right materials arrive at the right time, in the right quantity, and under the right conditions. Organization and scheduling follow closely. Scheduling answers the question of when and how deliveries are planned, whether there are time windows for delivery, and how arrival peaks are managed to avoid bottlenecks at the receiving docks. Supply transports refer to the physical movement of goods from suppliers to the warehouse, typically involving trucks, sometimes also containers or rail wagons, depending on the network setup. Collection tours can be an efficient method, where one truck picks up material from multiple suppliers in one trip. This is a strategy often used by automotive companies, for instance, where milk run concepts help reduce inbound transport costs and consolidate small shipments. Once the goods physically arrive at the warehouse, we move into the internal processes, starting with receiving. Receiving is far more than just unloading trucks. It includes unloading entrance control, that is, checking that what arrives matches what was ordered, buffering if unloading must happen quickly, and repacking if the goods arrive in transport packaging not suitable for storage. Let's take an example. Imagine a shipment of electronic components arriving on mixed pallets. In the receiving area, these components may have to be separated, checked, and repacked into standard totes before being moved further into the warehouse. Closely tied to receiving is the processing step. Processing involves labeling, quality control, and possibly changing the load carrier. For example, goods arriving on wooden pallets may be transferred onto hygienic plastic pallets for use in a food warehouse. Processing also includes preparation for storage. That might mean creating barcodes, assigning storage locations, or updating the warehouse management system so that downstream processes can find and access the goods quickly and efficiently. Especially in high-throughput environments, automation can play a major role here. Automatic label applicators, pallet inverters, or check weighing stations are examples of equipment commonly found in processing zones. After processing, the next stage is storing. Storing means physically putting goods into the warehouse storage system. It's not just about putting items somewhere, it's about putting them in the right place, in the right way, according to a defined strategy. Storage strategies can vary. There are fixed location systems where each item has an assigned home. There are chaotic or dynamic storage systems where inventory is placed wherever space is available and the system tracks the location electronically. A high bay automated storage and retrieval system, or ISCS, is a good example where dynamic storage is the norm. Storing also includes considerations like retrieval. Some warehouses optimize storage, not only for space but also for fast and efficient picking later. For example, fast-moving items are stored closer to the picking stations, while slow movers are stored farther away. Once goods are stored, the next big block of warehouse activities centers around order picking, called commissioning in the figure, but I recommend you stick to order picking. Picking is triggered either by external orders from customers or by internal orders, such as replenishment for a production line. Picking can take many forms: piece picking, case picking, pallet picking. And different strategies exist, from person-to-goods systems, where employees walk to the items, to goods-to-person systems, where automation brings the items to the picker. An example of goods-to-person technology would be AutoStore systems, shuttle-based ASRS systems, or vertical lift modules. The choice between these systems depends on many factors: throughput, order profiles, labor costs, space constraints, and so on. After picking, the next step is packing. Packing consolidates picked items into shipping units suitable for transport. This might involve placing individual products into boxes, stacking boxes onto pallets, or combining multiple small parcels into a larger container to optimize shipping costs. There is a key distinction between one-way and multi-way packaging. One-way packaging is disposable, typically cardboard cartons. Multi-way packaging is reusable, like plastic totes or collapsible crates. The choice has big implications for cost, sustainability, and logistics network design. In closed-loop supply chains, such as between manufacturing plants and suppliers, multi-way packaging is often the better option despite higher upfront costs. Once items are packed, they move into the dispatch area. Dispatch includes order consolidation, bringing together all items for a shipment, compressing and optimizing the load, checkout processes, buffering if there is a delay before shipment, and finally, loading the goods onto outbound vehicles. This phase must be highly synchronized with transport planning. Late or incorrect dispatch can lead to missed delivery windows, penalties, and dissatisfied customers. In modern warehouses, dispatch areas are equipped with staging lanes, buffer zones, and dock management systems that help manage vehicle arrivals and departures efficiently. At the bottom of the internal warehouse processes, we see the disposal step. Disposal includes handling empty packaging, waste material, damaged goods, and returns. Not all goods that enter a warehouse leave as saleable product. Some goods are damaged on arrival, damaged during storage, expire, or are recalled. Efficient disposal processes ensure that such goods are identified, handled according to legal requirements, and, where possible, recycled or reused. Returns management, as we discussed earlier, is often tied into disposal processes, but can also involve additional refurbishment, reconditioning, or resale pathways. Now, having completed the main internal processes, the flow continues externally. On the customer side, we move into distribution. Distribution includes replenishment of downstream facilities, organization and scheduling of delivery transports, and the execution of delivery tours. For example, milk run deliveries to retail stores or regional depots. And it's important to recognize that distribution is not just about shipping parcels. It's about designing and managing an entire downstream flow that meets service level requirements while minimizing cost. This might involve decisions such as cross-docking, where goods are not stored at all, but immediately sorted and sent out again, or hub and spoke models, where goods flow through regional distribution centers. And just like on the supply side, there is a return flow from the customer side. Products may be returned because of defects, customer cancellations, overstock, or expired products. This return flow must be planned for, structured, and integrated into the overall logistics network. Neglecting returns management can lead to bottlenecks, confusion, and significant loss of value. And if we step back and look at the entire model shown on this slide, we can see that a warehouse is much more than just a storage facility. It's a dynamic, interconnected system of processes that must be carefully coordinated, optimized, and continuously improved. Each process step, from receiving to processing, storing, picking, packing, dispatch, and even disposal, adds value, reduces waste, and contributes to the overall performance of the supply network. And each process must be designed based on a clear understanding of the business model, the product characteristics, and the customer requirements. For example, a warehouse serving a retail apparel chain will have very different picking and packing processes than a warehouse supplying spare parts to an automotive manufacturer. A pharmaceutical distribution center will have different receiving and quality control processes than a consumer electronics fulfillment center. There is no one-size-fits-all design. Every warehouse must balance space, time, cost, service, and flexibility. And the way the internal processes are designed is key to achieving that balance. In the next parts of this course, we will go deeper into specific warehouse process designs. We'll look at receiving docks and how to optimize their layout. We'll discuss picking strategies like zone picking, batch picking, and wave picking. We'll study different packing stations and dispatch area designs. And we'll explore technologies that automate or support these processes, from barcode scanning to conveyor systems to warehouse management systems. Understanding the structure shown on this slide and the logic behind the process flow is therefore not just theoretical. It's foundational knowledge for anyone involved in warehouse engineering, warehouse operations, or supply chain management